last class we studied about cyclic quadrilaterals. Their vertices lie on the circumference of a circle and the sum of their opposite angles is what? It is 180 degrees. Now based on this information, let us try to solve some questions. Now look at this question. You are given a quadrilateral. What type of a quadrilateral is it? It is cyclic. Why? Because all the four vertices of the quadrilateral lie on the circumference of a circle, which means this quadrilateral is cyclic, or in other words, it means the opposite sides added should give you 180. What else are you given? You are given two angles. You have to find these two angles. Now, instead of finding out what C is, won't it be enough if we find what A is? Because angle A plus angle C will give you 180, because these are the opposite vertices of a cyclic quadrilateral. So we already know a bit of A. What about the other bit? Angle A is what? It is CAB plus CAD. Already one part is given as 40. Now you need to find what CAD is. Can you find any other angle whose arms end at CD? Then what theorem will they follow? If you take any arc, then the angle that the arc forms at any part of the circumference will be equal. So you have a CD. There it makes one angle. Is there any other angle you can think of? Look at this. CBD. You don't even have to look at the illustration. You just have to write this. Their arms should end at CD. This arc, their arms should end here, then they will be equal. You don't even have to look at the picture. One important point, this A and B should be on the circumference. It should not be inside or outside the circle. So CAD and CBD are equal, which means what? This is also 80 degrees, and added they will give you 120. Just look at this picture. See, starts and ends at CD. This also starts and ends at CD. So this and this will both be equal. So if this much is 80, together they will give you 120. If this is 120, both added should give you what? 180. That means this whole thing is now 60. But that is not what we want. We want each one separately. We want each of these angles separately. So for that, what will we do? Look at what else is given. AB is equal to BC. Now consider a triangle which will have AB and BC as its sides. Only then we can apply the angles opposite to equal sides, that theorem. So why don't we take ABC? Here ABC, put all the vertices together, get a triangle. You have ABC. AB and BC are same, which means they're opposite angles. Again, don't even look at the illustration. A and B, what is the only vertex left out? It is C. And B and C, what is the only one left out? It is A. Now the remaining two vertices, put in whatever form you want. A here, B here, does not matter. Whatever form you want, just put the other two vertices. These are your two angles. But then what is BAC? It is given as 40. That means this is also 40. So there you have, this is 40. And that means this is 20. This is your answer. Now look at this question. You are given a quadrilateral. You don't know anything more about it. It is not a parallelogram so that you can say that the opposite angles are equal. You don't know anything. It is just a plain simple quadrilateral. Then the only thing you can say about it is A and B and C and B. All the four angles added will give you 360. There is nothing more you can know about this quadrilateral. What else is given? The internal angle bisectors. Each of this line splits the angle into two equal parts. Now these four lines come and meet in a small little quadrilateral. What you have to prove is that this small quadrilateral here is cyclic. What do you know about cyclic quadrilaterals? Their opposite angles. The opposite angles should be what? It should be 180. So just prove one of them. Prove this angle plus this angle is equal to 180. That is enough. Why? Because all the four angles added, always if it is a quadrilateral, all the four angles added will give you 360. If just this is 180, the other two will automatically, that will also become 180. So just take these two angles and prove that they are 180. And how are you going to do that? There is absolutely no way that you can prove anything about what is inside. But then consider what is outside. Now let me write the name properly. I have written it as E and H, but its actual name is FEG, this inside angle, and the other is what? FHG. These are the two angles that we have to add, and we have to prove that it is equal to 180. We are going to the outside angles. Will that help? Yes. Why is that? Remember all these figures. Whenever you have lines, remember these three figures. When something looks like this, it is the vertically opposite angles, which means it will be what? It will be equal. That is exactly what you have here. Do you see the X-like figure? So these are vertically opposite, they will be equal. Again, remember this figure, we are not dealing it with here, but remember it. Whenever you have two parallel lines and a Z-like figure, then these two will be equal, because they will be the alternate angles. And also remember this figure, these two added will give 180. These two will be equal. These angles will be equal, but these two angles will give you 180. Here we are only using this one, the vertically opposite angle. These two angles, what is inside and outside, it will be equal. So we will just find the value for this one, and we make a triangle which will have this as one of its sides. What about AEB? Look at that. That is a triangle. It has this side, but what about the other two sides? This is the whole of A. This line is cutting into half, so this line is A by 2 and this line is B by 2. All of them added will give you 180. Now what about this angle here? Can you think of a triangle which will include this? What about DHC? This is an internal angle bisector, which means it cuts the angle into two equal parts. So it is D by 2, C by 2 plus DHC, that is equal to 180. You have two different equations. Add them together, 180 plus 180, 360. Write these two angles as they are and look at the other four. Angle A, angle B, angle C, angle D, all of them added should give you what? It should give you 360. But then it is the half of all of that. Take half out. This whole thing will be 360 by half. The half of 360 is what? 180. So this, both of them added is 180. But then what is your AEB? It is the same as FEG. Why? Because remember X, it is vertically opposite. Similarly DHC, it is the same as FHG. This is 180, which means what? The quadrilateral that you have here, the small one which you have here, its opposite sides adds up to 180 degrees. Now look at this question. All you are given is just a little angle here. Given that you have to find two other angles. What are they? One is BEC and the other one is ABC. Just with this information, how will you start? You are given equality of three sides. So take any two of them and connect them with a triangle. So shall I take CD and AC first? AC here, CD here. Make all the three of them, A and C and D, connect them and bring them together in a triangle form, triangle ACD, that will have both CE and DE and A. all of it is included here, then AC will be equal to CD, which means the opposite angles. AC opposite angle is D. Just don't write D. Include the other two vertices also in whichever form you want. Here also just don't write A. Include the other two vertices whichever way you want. You can write that. Now these two angles are same. Don't even look at the picture. You see that DAC comes here. That is, this is equal to 38. One angle here, one angle here, the third angle here. What will that be? That will be 180 minus sum of these two, which means 180 minus 76. This one is 104. That means what? This one will be what? 76. Why? Because this makes a linear pair here. You see the linear pair? Both the angles together should give you 180. Any line, it will make the angle 180. So if this is 104, this is 76. That is one part done. Now look at the other equality. What does it say? It says AB and AC are equal. That means this side and this side are equal. Bring them together. A and B and C, bring them together in a triangle. Consider ABC. AB is equal to AC. Consider the opposite angles C and B. Don't just write C and B. Write the other two vertices in whichever form you want. Just write like this. Now we have already found out ACB. What is that? We have found out it is 76. So that means this will also be 76. That leaves what? That leaves the third angle A. Now not the whole angle. You see this? It is just confined to three vertices, A and B and C. Don't take the whole A. Don't go towards the D part. We are just concerned about these three vertices. Limit your calculations to three of them. 76 here, 76 here. The third angle will be this. And what will be its value? 180 minus sum of these two, because the sum of three angles in a triangle will give you 180, which means what? 180 minus 152 is what? 28 degrees. Now this is 28 degrees. Now I have just written A. That is very dangerous. A means the whole of this A. It is not 28. So please write it clearly. It has the other two vertices. Our triangle is just ABC. So it is confined to these two vertices. Now you have got ABC. There, your ABC is 56. Look at the other one, BEC. How do we find that? Can we find any other angle which the chord BC makes? That's all we need, right? If we have any chord, then the angle, whichever angle it meets at any point on the circumference, will always be equal. However many points it makes angle, it will be equal. But remember, only this side. Don't come to the arc. This is the arc. Don't come to the arc region. Just stay up there. So BEC, anything else ending with BC? Look at this, BAC. So that will be same. Why? Because you look at this is your arc. It makes one angle here, it makes another angle here. So if this is 28, this is also 28, and that is the answer you need. Now that's a few questions on cyclic quadrilaterals done. Till I meet you again. Assalamu alaikum.